So, after yesterday's heat treating video, or at least that's where we left off, this is what we're left with. So this is out after tempering and cut out of the foil packet. So this one came out pretty good. A little dark on the ends and here, but I think we'll be fine. If you notice in the video, the bags are both puffed up, so that means the bags became unsealed. If they don't have a tear or anything in them, they'll stay flat. So obviously, I still suck at folding those bags, and maybe I should actually spend the additional money and buy the ones from McMaster. But like I said, I had all that foil anyways. And then here's the other one. So you can see, obviously quite a lot of oxygen was hitting this top area, but for my very limited experience, and I'm probably like 50 blades into from the other knife and this one, heat treating in general, as long as it didn't like actually start like eating the steel, like actually, I'm not sure what the term is, where it starts to degrade the like dimensional quality, I found the heat treat is really largely unaffected as far as like that area of hardness. But obviously I don't really know what I'm doing, so someone can chime in who does and tell me I have no idea what I'm doing, as I just established. But anyways, it's better than bad. So yeah. So what I'll probably do in this video is we'll just do surface grinding, and then I'll leave all the hard milling stuff for a final video, just because the hard milling stuff is actually a really long, arduous process. And then maybe I'll break it up into like a fourth video, and I'll talk about like the hand finishing side of it and the struggles I've been having. But I'll kind of see how hard milling goes. But I'll probably film everything today. Alright, so this is the surface grinder I have. If you've seen my other knife videos, you know that I have this surface grinder. Fabulous description. This is a Tormach PSG 612. You guys can read. You've seen these before. If you're familiar with you know, cheap surface grinders you can buy for your house. Actually not that cheap. I think retail for like a bare bones one is like $4 grand, or maybe that's a deluxe one. I don't know. They're pretty expensive. I bought this one off Craigslist when Craigslist was still cool, which is like 3 years ago, and then Facebook Marketplace came over and basically wiped out Craigslist. And then quality went even more downhill. Anyways, so I bought this used. Doesn't matter where from, but what is important is they put this nice dent in the chuck. So there is a 1 thou dip right in the middle of the chuck. Now, when I got the thing the first year, and this has been like 2 years now, I ground in the chuck, and that was good, but the dip was actually cut even 1 thou lower, and when you grind in a chuck, when I did it, I don't think I was taking, you don't take that much of a pass, or like a large depth of cut. Forewarning for anyone watching, I have no idea what I'm doing as far as surface grinding goes. So if I say things, they're basically things I've read, and yeah, that's my disclaimer. I have no idea what I'm doing. So I needed a surface grinder to get the blades very flat. Now the idea is you heat treat and then you surface grind leftover material on the blades. That way you have very good like dimensional accuracy. So there's flatness, and then there's also parallelism, which is like, you know, two parallel faces. How parallel are they? Like, so the distance between one side and then the distance between the other side, do they measure the same? I guess that's parallelism. But then you could have a bow in the middle. So it gets kind of like complicated trying to like wrap your head around what flat and what parallel is. A surface can be flat, but not parallel to its, you know, supposed parallel face. Whatever. The point is, the blades need to be, I think most importantly, they need to be parallel to the faces that ride along the bearings. Flatness, obviously, is important, but the parallelism between the sandwiched handles and your bearings, I feel like that's, you know, really the point of having a surface grind. Then another thing is you have repeatability, like dimensionally. So if I say I want to have 1/8 blades stock that goes onto the fixture, then it's very easy to hit 1/8 within, you know, like 4/10 with this thing, and be very repeatable. If you're just facing things on the mill, what happens is, you know, maybe the mill is warm or the mill is cold, so it faces at a different height, the cutter's dull, blah blah blah. You know, there's a lot more variables in play than the surface grinder, which has a chuck, which, you know, is somewhat stable. Somewhat. This is all in the realm of somewhat. Yeah, so that's why surface grinders are good, and they're good for knife making. Now, something I do want to mention is a surface ground surface is actually really not good for knife making, I found, as far as like finishes go. So if you want to acid etch something that's been surface ground, you're probably going to find that the acid goes into the valleys of the surface ground surface and gives these like terrible, you know, straight lines, and it makes the finish look, well, bad, because an acid etch finish is really supposed to be kind of the same color. And what I found is surface ground surfaces are not actually level. They have very deep valleys, very deep, all relative. Yeah, so what I end up having to do is they come off the surface grinder, and then I'm actually hand lapping them on the surface plate with sandpaper, which I will show you guys. Yeah, so this isn't the be-all solution. I have looked at getting like a lapping machine, but that's really expensive. Like, to get an actual, even a used lapping machine on eBay is like stupid money, because I need one that's like at least a 5-inch dish on it, and then you get into lapping, and then, you know, that's a lot more science. Anyways, let's actually surface grind. Enough rambling. So before I start surface grinding, I basically measure to see how much material we have, and then I'll use that as a baseline. Then we dress the wheel for the surface grinder, pretty important. Spend a long time putting the blades on the right place in the surface grinding chuck where that dip is not located, but you can kind of see the little shadow in the back there. Then spend a tremendous amount of time actually finding the correct cut height, and I just try to cut at like 5/10 depth of cut, because the Tormach doesn't really have the horsepower to cut really anything deeper than 5/10 and not destroy the wheel, it seems. Then for these first roughing passes, I kind of just do this back and forth one with a pretty wide width of cut, and then like I said, the depth of cut is just like 5/10 if I can help it. Going deeper than 5/10 depth of cut seems to like load the wheel up, and then it really doesn't cut. You can kind of hear it when it doesn't cut. It makes like a kind of low tone sound, and when it does that low tone sound, then it kind of leaves these kind of weird wavy marks on the part. So this is kind of after the first set of roughing passes. You can see one of the blades is being cut quite a bit, but the other isn't, just on the backside. So it's like a pretty common thing with surface grinding, I've found. So that's kind of why I leave quite a bit of material, at least for now. And then, you know, that way it gives you a lot of room in case you mess up or something. Here the wheel is taking kind of a bit too much of a depth of cut here, and you can kind of hear it, and the surface finish it leaves is not that good. So I ended up redressing it, I think, here, and then started taking not as crazy as a depth of cut. The issue with taking like a big depth of cut is it dumps a ton of heat into the part, and then the heat basically warps the blades in unpredictable ways, or into the wheel sometimes. So you kind of want to avoid taking too big of a cut. So this is actually the final cutting pass I use. So I redressed it right before this. I take an extremely shallow depth of cut, an extremely shallow like width of cut. So it's probably like 1/16 width of cut, and I get a pretty nice surface finish doing this. So this is after doing that finish pass. So you get a pretty nice surface finish. Then what I'm going to check is how much we've actually taken off. So it's 127 in the middle, but it ends up being like 129 on this backside where the material's thicker. And then up on the front, it goes back to like near 127. So I'm just kind of trying to see where if there's any weird crazy dips. After that, do a redress for the second side. So we're flipped over now. And you'll notice, at least I noticed, that the second side, the center, like the center of the parts will always cut last and the outsides are higher. So it's just something I've always noticed. So it's kind of like you want to flip the part over a couple times to get it like trued up to the chuck. At least that's what I think. And then, so what I'll do is like, I'll do a first roughing pass, get it cleaned up, flip it over, do a nice finish pass on this side where we're cutting. And then I'll flip it over one more time. And then that'll give us like as close to the chuck as I can get it, basically, with like a really low width of cut and depth of cut, so I'm not dumping heat into the part. So that's usually what I try to do, but I don't know, results vary. I get pretty good results this way. I don't have coolant on the surface grinder. That's apparently like flood coolant is kind of the way to go for sure, but if you don't have any, then you kind of have to be conscious of how much heat you're dumping in the part. So you're gonna do a final dress, and then this is another cleanup pass. So here I'm cleaning up this side with a really low depth of cut and width of cut to get as best of a surface finish as possible. Then after basically doing a couple flips and walking down to our final dimension and doing a final dress and a final cut, we got 1259 on the end, 1259 in the center, and then really close to 1259 in the front area. And I'm just leaving close to a thou left just because I'm going to hand lap these in a second. The surface finish I get off the grinder is actually pretty nice as far as I think for my skill level, and then the quality of the grinder. I'm not sure if I'm using necessarily the correct wheel, but it seems to give me pretty decent results. So here I'm hand lapping the blades, so that means I took a piece of sandpaper, this is 120 grit, on a surface plate, and I'm going in figure eights and basically trying to sand the blades down to remove any of the surface grinder marks. And you can kind of see the result after the first set of passes. You can still see the marks in there. You want it to be basically completely scratched up. After that, move to 220 grit, same goal, trying to remove the previous scratches and try to get a really uniform surface. You can see I started getting lazy and I started pushing the work on the sandpaper, trying to cut it faster, which does kind of work. Something to note is those little scratch marks where I'm pointing right now. Those are a huge pain to get out, and I think a dull grinder wheel causes those to show up. So I try my best, but yeah, it's still a lot of work. Alright, so I've been sanding for what seems like an hour and a half, actually has been an hour and a half. And this is how far I got. Here we go, this is up to 400 grit. Now you'll notice that it's completely uneven, which is totally expected because we have hand pressure. These marks here that at the top that we left from surface grinding, those are mill marks from when the stock was, you know, milled from wherever they mill steel, I guess. So I'm not too worried about those though, because they're gonna get cut off, so that's not a big deal. I think I showed you guys the worst scratches. Now here is, I started sanding this side, and you're supposed to go in figure eights, but going in figure eights takes forever with this sandpaper. So I ended up just pushing like back and forth, but then you get an uneven like grind, I guess, uneven sanding. So yeah, I'm not really sure what the best way to do what I'm trying to do. You might not really understand what's going on, but if you look at this one, see these lines here? Yeah, these little ripples, were kind of like the surface grinding wheel bounced along the surface. So those are actually like valleys in the surface. And when you go to like acid etch or tumble the blade or even sandblast the blade, it actually shows those lines really defined. Just something, you know, it's a surface deviation, and it's what's the word I'm looking for? It's magnified when you know, you try to basically do any sort of post-process treatment to the blade. And another issue is right here in this plane, like at a 45 near the pivot, there's these scratch marks, and I've noticed these scratch marks come from the wheel being dull, but I didn't catch them on the grinder before I took them off, so yeah. I mean, I have a couple issues obviously with this process. One, it's tremendously slow, and I hate it. And you probably lose the parallelism you were getting from the surface grinder a little bit, like not that much because you're still on the surface plate, but it's yeah, it's a really manual process, and I don't like it. It takes a really long time, and really, you do all this work to do this. You're cutting a lot of surface area by hand, and you end up cutting a lot of it off on the mill. The reason I do this before milling it is because the part is flat, and trying to actually like lap the blades when the bevel's cut is practically impossible, because what happens is if you put any accidental pressure on the side of the blade, it'll push the cut bevel right into the sandpaper, and then you'll have a huge scratch on your bevel. So that's why I'm doing this prior. But yeah, what I need is a lapping machine. That would be the best. Or maybe the second next best would get actual lapping plates with diamond paste. That's probably cut this hardened steel a lot quicker than this terrible sandpaper. So yeah, that's kind of where I'm at blade process wise. And this doesn't change the fact that I still have to hand sand every part of the blade even after they get hard milled, even though the finish comes out really good. So yeah, this is by far the longest part on the entire knife. Yeah. So anyways, tomorrow we're going to hard mill. That'll be cool. And yeah, so that's the end of this video. Thanks for sticking around. This one's kind of boring, but sanding and lapping and making things flat and parallel is pretty boring actually. So yeah. Anyways, catch you on the next one. Have a nice night.